My name is Pax Haymeyer. I am the Director of Academic Programs and the manager of the Stanford Advanced Computer Security Program here at the Stanford Center for Professional Development. And it is my pleasure to be hosting Dan Boneh and Neil Daswani today as they give us the landscape of the cybersecurity market and help you understand that landscape in order to build a comprehensive security solution for your organization. So with that, let me introduce our presenters today. Dan Boneh is the co-director of the Stanford Advanced Computer Security Program and professor in computer science and electrical engineering here at Stanford. He heads the Applied Cryptography Group and co-directs the Computer Security Lab here. He is the recipient of multiple awards. I won't go into all of them, but what I do want to also emphasize is that he's a really innovative educator, and not just for the online programs he's developed with us, but he also has a MOOC on cryptography, as well as an online textbook available at cryptobook.us. So that's a graduate-level textbook on cryptography at cryptobook.us. It's freely available, and I believe you'll be doing a new update on that book in January. It is also my pleasure to introduce Neil Daswani. Neil is also the co-director of the Stanford Advanced Computer Security Program. He is an accomplished technical visionary, angel investor, and internet security leader who has served in a variety of research, development, teaching, and executive roles. For example, he was the Chief Information Security Officer at LifeLock and at Symantec's Consumer Business Unit. He is also the co-author of an upcoming book on big breaches, which will be coming out in early 2021. As well as Foundations of Security, What Every Programmer Needs to Know, which has been out and is an excellent book. I've read it. So with that, I am going to go ahead and hand the webinar over to Neil and Dan.
Great. Thank you very much, Pax. So let me first start off by saying that cybersecurity has become a huge market, a large market. Irrespective of which industry analysts you look at, whether it's Gartner or IDC, there's over $100 billion that gets spent per year on cybersecurity solutions. The field is growing at a 9 to 10% growth rate, some areas faster than others. You can see that there's some areas here in managed security services that are in fact growing at 14.2%, other areas at 10% and whatnot. There's even some industry analysts that expect that the market will be a $300 billion market by 2024, which is a little bit aggressive. There are over 3,900 companies in the cybersecurity space that have been funded over the past 15 years. There's just some of them that are shown on this diagram here for Momentum Cyber. This particular slide divides up the cybersecurity landscape into about 18 or so categories. It's not the only way to divide it up, but the thing to take away from this slide is that there are lots of companies. The space is generally quite fragmented, and there's a lot of mergers and acquisition type activity in it. We can chat more about that at the end of the presentation if we have time. There's no way to cover the entire cybersecurity landscape in this 1-hour presentation, but what we'll do is we'll cover 5 to 6 of the categories and talk about some examples within each. So with that, to start us off, I'll turn it over to Dan, who will tell us about identity and access management.
Yep. Thank you, Neil. So welcome, everyone. First of all, thanks all for joining us. This should be a fun hour, and we're happy to take questions and discuss with you these topics at the end of the hour. Let's see. So like Neil said, the security space is vast and huge. There's just a huge number of companies, and even as you can see from this diagram, a very large number of categories. And so what we decided to do is just focus on a few categories that we're kind of excited about, and tell you about a few things that are happening in that space. So the first one we wanted to start with is identity and access management. So let's start just by kind of reviewing a few kind of issues in that space. So what is identity and access management? So already you can see from the diagram here on the upper right, there is a fair number of companies in the space. You can kind of break it up into even subcategories. So for example, there are a number of companies that provide services like identity as a service, so that you outsource your identity questions to these companies. And so companies like Okta and Duo and RSA, I think everybody's familiar with those. There are companies that provide second factor tokens like Yubico and Fition and RSA and so on. And then there are companies that provide general access management, either for kind of, here is where the market kind of bifurcates. There are companies that focus on access management for employees. These are the IAM companies. And there are companies that focus on identity and access management for customers. So those kind of products allow for self-registration and, more importantly, kind of self-service functionality. So that's kind of a high-level view of the space. What I wanted to talk a little bit about are some new things that are happening in the space. So specifically, I want to focus on second-factor tokens. One thing that's happened recently is, if you can see on the bottom right here, I listed some pictures of a number of tokens. One thing that's happened is a lot of these companies have added support for NFC to their tokens, which is kind of cool in that now you can use these tokens not just by plugging them into your laptop, but you can also use them with your phone, connect to your phone through NFC, and then do the authentication. So I kind of listed multiple products in the space that support NFC, so you can do authentication on your phone. So that's one thing that's kind of happened, just basically a broader support for second-factor tokens. I did want to bring up the fact that these second-factor tokens are extremely, extremely important. And so there's this really kind of well-regarded announcement that Google made a few years ago, I guess back in 2017, saying that they kind of distributed these tokens throughout their user base, throughout their employee base. And as a result, there have been basically no phishing attacks on Google employees basically since 2017. This is kind of a remarkable achievement. So this does say something about the power of these second-factor tokens. So and again, I wanted to talk about a few things that have kind of happened in the space. And so one interesting development with second-factor tokens is this WebAuthn and CTAP standards. So I hope you can read the font here. It's a little small, but basically what WebAuthn does is it brings second-factor authentication brings native support for second-factor authentication to the web. In particular, it adds in-browser JavaScript support for interacting with these second-factor tokens. So effectively, the authentication, so when you connect to a remote website, authentication is done using a second-factor token that you hold in your hand. You can plug it into your computer or connect it to your computer via NFC. It also supports browser-based long-term secrets that can be used for authenticating users to remote websites. So basically, this is kind of a way to provide much better challenge response authentication protocols for remote websites. So if your website has a need for remote authentication, definitely look into integrating it with WebAuthn. Either you would do it yourself, or you would do it through the identity as a service providers like Duo and Okta that already work with WebAuthn. In fact, one of the nice websites that explains how WebAuthn works is due to Duo. I wanted to show you how this works. So this is quite widely supported in all the major browsers. Chrome, Firefox, Edge, and Safari support is coming. And so you can even look at this caniuse.com website, which shows you which web features are supported by which browsers. You'll see it's actually quite widely supported. And again, I just wanted to drill into the details a little bit. Basically, WebAuthn supports two steps. There's a registration process, there's an authentication process, and all that is done through the browser. So in fact, there's a browser object called navigator.credentials.create that lets you create credentials for a user. You're a website that lets you create credentials on the user's browser. And then there's when you want to do authentication, there's a navigator credentials.get, which allows the browsers to use the credentials that you created. Yeah, and like I said, you can kind of integrate these things yourself into your website, or you can use Duo or Okta to do the integration for you. And again, the point is to move away from SMS to these much better second-factor authentication systems that, like we said, support challenge response, which is a better way to do authentication. So that's what I wanted to talk about for WebAuthn. There's one more thing that I wanted to mention in the authentication space, specifically about password management. This is kind of a very cute thing that Google rolled out recently. So I just wanted to mention and make sure you know about this. So the problem is the following. Google was able to obtain a very large set of compromised passwords. As you know, there are large data sets of compromised passwords constantly being discovered. And you can go and buy those password databases. So Google kind of has a very large set of compromised passwords like 1234556 and ABC123. Hopefully here nobody here uses those passwords. And if you are using one of those passwords, please go ahead and change that right away. Anyhow, what they wanted to do was allow their browser to basically enable the user to test whether the user's password has been compromised. So when the user types in a password into the browser in the password field, what the Chrome browser and now other browsers too, what they will automatically do, or what they would like to do, is they would like to send the user's password to Google so that Google can check whether the password has been compromised. Then Google would respond back saying, no, this password has not been compromised, or it has. And if it has been compromised, then the browser immediately alerts the user to go ahead and change their password. So this is a kind of a pretty nice capability to have. But if you think about this for a second, you realize this is a pretty bad idea, because effectively the user will be sending all their passwords to Google, which is not something we want, right? If I have a password with a random website, I don't want that password being sent to Google, even if it's done for good purposes. So the question was, how do you implement a system like this? And here is where interesting conflicts between privacy and security come up, right? From a security point of view, we'd like to send our password, but from a privacy point of view, we cannot. And so the question is how to resolve that tension. And so this system was actually deployed using very clever cryptography, using techniques called private information retrieval, which allows you to test whether an item is in a remote database without ever telling the remote database what you're actually testing for. Yeah, so this is kind of cool in that you can now test whether your password is in the remote database without ever revealing to Google what your password is. Yeah, so if you want to read more about how this works, I have the link down here. And so this was kind of a cute a deployment of cryptography that happened recently. And I wanted you to be aware that this is something that basically the public now has available for use. Okay, so I'll stop here and hand it over to Neil.
Great, thank you, Dan. So I'm going to continue by talking about the next category, which is Internet of Things security. For those of you that haven't heard the term Internet of Things before, although I expect most of you have, I'll tell you, I first started hearing this term around 2011, 2012, sometime in that range, and it basically refers to the billions of devices that are coming online on the internet that are not servers or laptops or mobile phones. If we think about all the devices in our homes these days, webcams, doorbell cams, Amazon Alexas, Nest thermostats, all kinds of devices that plug into your home automation system, whether they be sensors like smoke alarms or whether they be devices that do something based on sensor data like light bulbs. There's expected to be 20 billion of these types of devices deployed by 2025. There's only 8 billion people expected to be on the face of the earth by 2025, so that's a significant number of devices. Now, these devices have typically been engineered to be as low cost as possible, and even if security has been a design criterion for some of them, it typically has not been the highest priority. And so as a result, there's tons of these IoT devices that perhaps cannot even be patched. If there's a security vulnerability found in the code that runs on these devices, it may not even be possible to update the code so that the device is now not vulnerable anymore. Even if the device is capable of being patched, it may not get patched regularly. Because these devices are also deployed by end users, your average everyday folk, they may not configure those devices. They may leave the default password in place. And there have been botnets like Mirai that have infected hundreds of thousands of these machines and sent traffic to Netflix and Twitter and basically knocked out those sites for some period of hours because of these vulnerabilities. There's in general a lack of security standards in the Internet of Things space. So as compared to, for instance, when you buy any other electrical device, there's typically a sign-off from Underwriter Labs and a tag that you can see on the device. There is no similar safety or security certification that's become very widespread in the Internet of Things space, although there are a few things coming up in that. So in any case, this is what IoT security is all about. How do we secure all of these devices, and how do we secure all of the implications that can result from these devices getting impacted by malware or other things? So if we think about what's new in this space, well, earlier this year, we went from a scenario where maybe 16% of all workers were remote, and due to COVID-19, 95% of people were required to work from home. And even when the world returns to some semblance of more normalcy, the expectation is that there's still going to be many more remote workers than there was before. Now, how does that have anything to do with IoT security? Well, you've got people working at home. They've got their corporate devices now on their home network, and they also have a lot of these IoT devices. They're Amazon Alexas and other devices on their home network, some of which could be vulnerable and could get hacked. I'll tell you, just a few weeks ago, my firewall at home started giving me alerts because my DVR that records all the footage from my home cameras was under attack by a botnet. And of course, the first thing I did is I just shut the thing down, because it's okay if my cameras don't work for a few hours, but I definitely don't want my home network to get hacked. And now that my corporate device is running in that home network, attackers can compromise IoT devices in the home and then use those to attack corporate laptops or other corporate resources. So the question is, how do we protect all these corporate devices from the IoT devices? The other challenge that companies have is that you can't necessarily trust the home routers, because they could still have default passwords. They could have their DNS hacked, the service that translates domain names to IP addresses. And once the attacker takes that, it's kind of game over. So there have been a whole bunch of new solutions that have started entering the market. Companies like CyberX and whatnot, they basically give enterprises tools so that they can manage the Internet of Things devices, either in their enterprises or potentially otherwise. The concept of zero trust has also been an important concept in the field, in which it used to be the case that you used to rely on an intranet or some corporate network, and once somebody was on the corporate network, you can assume that it's secure and whatnot. But the concept of zero trust says, no, that's not the right way to look at this. Instead of relying on some perimeter network, and there's inevitably going to be compromised devices in any network, the concept of zero trust says, you know what, let's not trust any of the devices. Let's, every time that a device or a user connects in, let's authenticate the user's identity, let's authenticate the device, and only let it on the network if we can confirm that it can be trusted. But you got to verify every time, and you don't trust something just because it happens to be on the network. So the question is, how can we set up an environment in people's homes where they can work more security, given the fact that there's threats from these IoT devices, and given the fact that we'd like to have zero trust. So there's solutions like BIOS that have come out recently, where it's a piece of hardware that you stick into your laptop. It basically relies on your home router only for transport. It does not even rely on your home router for DNS, to convert domain names to IP addresses, and basically takes your corporate device and puts it on a microsegment of 1. So whereas the home network used to typically just be flat and any device on the network could communicate with any other device on the network, once you stick in a BIOS device in your corporate laptop, it segments it off so that nothing on your home network can even communicate. So anyhow, that's IoT security and some of the new solutions coming out, given what's been going on in the world. With that, I'll hand it back over to Dan to chat about cloud security.
Great, thanks, Neil. So I see that there are already a number of questions coming in, which is great. So keep the questions coming in, and we'll discuss those at the end of the presentation. So we're gonna, like we said, there are many sectors in the security space. We're kind of moving through these sectors pretty quickly. The next sector we wanted to talk about is cloud security. And so again, cloud security is a pretty large topic with lots and lots of companies in the space. In fact, we're putting together a whole course right now, a whole online course for the program just on cloud security and how to manage your containers in the cloud well and so on. But if I can break the space into kind of 3 high-level categories, well, obviously there's the CASB providers, the cloud access security brokers. These are companies that basically provide tools that sit between the cloud user and the cloud provider, and they basically provide policy monitoring and enforcement. And how to properly use these tools is kind of a pretty interesting question in its own right, which we'll talk about in a second. There is a whole bunch of companies looking at container security, so making sure that the code that you upload to the cloud actually does what it's supposed to do and is hardened in one way or another. And there are, again, that sector breaks into folks who do external monitoring of the containers, so external scanning of containers to make sure everything is configured properly, or even internal monitoring where they provide tools that sit inside of the container. And then there are approaches that are kind of exciting to me personally, which is kind of what we call enclave-based cloud security, where basically all the cloud would provide an enclave-like capability. So this would be like a hardware component where all your containers in the cloud run inside of this hardware component, and no cloud administrator can see into the component. Yeah, so it's kind of either dedicated hardware or maybe on-chip hardware. But the point is you have a hardware firewall that prevents anyone from looking into what's happening inside of this hardware container. And so the promising vision here is that you could actually give jobs to the cloud. You can upload a container to the cloud. The cloud would only see encrypted data. So all your customer data, all your business data would always be encrypted in the cloud. The only place where it gets decrypted in the cloud is when it's inside of this container. But like we said, the container is protected from the outside world using hardware. So this is kind of an interesting vision where that we'll be moving to as soon as this is available, which basically allows you to kind of outsource jobs to the cloud, but minimizing the trust that you put in the cloud. Okay, so that's kind of roughly how the cloud security space breaks into the different sectors. I wanted to tell you a little bit about some recent research that we did that may be relevant to things that you're concerned about. So the specific problem I wanted to tell you about is what's called the question of key rotation in the cloud. Yeah, so what is the problem? Well, so we all have lots of data. We all manage lots of data. We'd rather not keep the data on our own premises or even in our business premises. We'd rather upload the data to the cloud. But then when we upload the data to the cloud, if the cloud doesn't need to actually operate on this data, we'd rather encrypt the data so that the cloud doesn't actually see the data in the clear, and then we keep the key to ourselves. Now, there's this operation called, the standard operation on encrypted data is called key rotation, which basically means periodically re-encrypt the data under a new key. And this is a good hygiene idea. This is a good idea to do. Let's say once a year or so, you would re-encrypt all your data, and then everything gets re-encrypted under a new key. So now the old key effectively becomes useless. And of course, we're assuming here that the cloud itself is trusted to delete the old ciphertexts, so that the rotation actually does really make sure that the old key is no longer useful for anything. Okay, so that's called key rotation. So why do we do key rotation? Well, basically what it says is, if you have a contractor that you hired into your organization and you gave them keys to your data, well, once they leave and you do a key rotation, the key that you gave them is no longer viable. So this is a way to sort of revoke a key, even though you gave it to someone and you might not be able to take the key back. You basically make the key be useless for that person. So again, that's one reason to do key rotation. It's kind of a good idea in its own right. It's like a periodic key rotation. It's also required by a number of standards. So I listed a couple of standards out there that have built-in requirements for either annual or semi-annual key rotation on all your data, just to make sure your keys are fresh at any given time. But when you try to do key rotation in the cloud, you very quickly run into a problem, right? If you want to rotate data in the cloud, well, how do you do it, right? So you have the keys, the cloud has the data, so how do you actually re-encrypt the data? So the obvious option is to just download the entire data from the cloud, re-encrypt it on-prem, and then upload the new ciphertext back to the cloud. That is horrendously expensive, because now you have to download all your data and re-encrypt and re-upload. So the networking costs are going to be quite high for this, especially if you have a lot of data. Of course, the other option is to send the old key to the cloud, send the new key to the cloud, and then allow the cloud to do the re-encryption itself. But of course, by doing this, you just gave the cloud access to all your data, which is what we were trying to avoid in the first place. So you see, key rotation in the cloud is kind of problematic because both naive solutions are impractical for one reason or another. So what we were interested in is basically a practical way to do this. And so there's a different way to encrypt data. It's called what's called updatable encryption. There are a number of papers on this that have appeared recently. And so let me just explain to you what it does. The idea is that, again, the data lives encrypted in the cloud, as you can see on the right. And on the left, the cloud customer basically has the old key and the new key. What the cloud customer does is they can somehow combine the old key and the new key into some mixed up key. Yeah, so this is like a nonsense key that reveals nothing about the old key and the new key by itself. You can send this update key. This is what's called the encryption update key. You can send that over to the cloud. That tells nothing. The cloud learns nothing about the old key or the new key, but that kind of mixed up key allows the cloud to re-encrypt your data, to do the rotation. So the amazing thing here is the cloud can do rotation, but the cloud learns nothing about the data that you're encrypted. So yes, so very little communication, and you're maintaining security. So it resolves the problem that we just mentioned with key rotation. So what can we do there? Well, so I linked to sort of a paper that we put out on how to do this. If you want to read more about this and about the state of the art in the space, the main point I wanted to point out is there are kind of reasonably efficient constructions to do this. One construction is called a nested construction, which is particularly practical. And if this is something that you're worried about, then in fact, this is something that is available to implement. So if this is something that's interesting to you, feel free to reach out, and I would be happy to discuss these kind of issues with you. Okay, so I will stop here, and we'll move on to the next sector, and I'll hand it back to Neil.
Great, thank you, Dan. I'm going to now chat a little bit about application security. Application security is a category that's probably been around for, 20 years or so. Sometimes it's called software security. But the idea is that if you are a company or any organization that develops software of your own, you've got to make sure that your own software is not vulnerable to all kinds of issues ranging from cross-site scripting to SQL injection to buffer overflows. There's been a whole bunch of different types of vulnerabilities, and application security is all about preventing, detecting, and eliminating such software vulnerabilities. So I'm just going to go through a few examples of what application security is about. And I'm a big fan of whenever you can design security into your systems such that vulnerabilities are not possible or highly unlikely, that's all the better. And so, for instance, if you look at what Google did, for instance, they basically designed a middleware web templating framework that pretty much all of their engineers and developers use, such that vulnerabilities like cross-site scripting and SQL injection are nearly impossible to happen. And so the way these things work is, for those of you that say aren't familiar with cross-site scripting, it's a problem where when a user provides input to a website, a user could put in characters or whatnot that, when echoed back by the website, confuse the browser into executing code that the site itself did not initially intend to execute. But basically, when such data is output back out to a browser, it is output escaped and converted into data and cannot be interpreted as code. It basically makes such attacks and such attack attempts inert. So whenever you can design in things like that, it's better. I provided a reference to a great talk that Christoph Kern of Google, co-author of my first book, gave on this particular topic. That said, whenever you can't use such a framework to make such vulnerabilities nearly impossible, you can do a number of things. You can run a number of tests on your code to see whether or not it might be vulnerable. One example of such tests are static analysis tests. And such tests look at the code without running it and try to identify vulnerabilities. So Coverity is an example of a startup that came out of Stanford research years ago, Dawson Engler and team, where they were able to identify such types of vulnerabilities without even running the code. Another example is dynamic analysis, where basically you run the code you run it in a sandbox or a test environment in such a way that you can exercise code paths, pipe in malicious input, and see what happens and how the code reacts, and if it ends up doing something, say, unexpected as a result. So that's DAST, or dynamic analysis. security testing. IAST is another acronym that's entered the field, and that is interactive application security testing. And the idea there is that if you have a bunch of unit test cases, or regression test cases, you can basically run those on the code and try to poke and prod the code into demonstrating a vulnerability. So, by the way, Tinfoil is an example of a company that did some great dynamic analysis, and actually both Tinfoil and Coverity got acquired by Synopsys. Synopsys, while they were traditionally a semiconductor design firm, they've basically created a software security business unit, and they have put together all these types of solutions. So that's another example of traditional application security. Yet another example is software composition analysis, where you might have to use a lot of third-party libraries in your code to get all kinds of functions done that you don't want to build yourself. And those libraries could have vulnerabilities. So what software composition analysis does is it figures out, well, what are all the different, say, third-party open source packages that you're using, and what are the vulnerabilities in those open source packages so that you could make sure you keep your libraries up to date. Black Duck is an example. Black Duck was also acquired by Synopsys. So this is what application security is about. Now, the traditional model in application security has been, you write some code, you then test it, you then fix it, you then deploy it. Given the interest from industry in speed and agility, the lines between development and testing are getting blurred with techniques like DevOps and SecDevOps, if you've heard any of these. And so another approach, a new approach, is to say that instead of having these distinct phases of development, testing, fixing, more development, testing, fixing, etc., a lot of companies have set up CI/CD pipelines, continuous integration, continuous delivery pipelines, where what the developers are doing is continuously rolling out new features. Sometimes there's multiple releases per day. And so the question is, if you have this kind of environment, how do you change the way you approach security testing? Well, the approach is more of an approach around observability, and it's more constant. So there's a whole variety of startups and tools, Contrast Security, Deepfactor, Opsera, Sysdig, that have focused on making sure that you are always observing what's running in test and staging and in production sometimes to determine what vulnerabilities exist. So to look at Deepfactor as an example, what Deepfactor does is it's continuously running, and it's looking for all kinds of vulnerability even when you're in test and staging. If some new developer introduces a library that wasn't getting used before, and there's some new process running, it'll help identify that and provide observability and visibility around that. And I'll show an example of results from Deepfactor. Opsera is a new startup that just launched earlier this year. And what they do is they will let you set up your CI/CD pipeline in such a way so that you can just kind of pick and choose what not only tools you use, like you use GitHub or whatnot, but it also lets you choose from a whole bunch of different security tools and integrate statistics and monitoring in dashboards so that you can continuously see how many vulnerabilities are in test and stage. And what that allows you to do is, for instance, like only launch when and only push out a new feature when any security issues have been addressed. So to provide an example of what these tools are doing, previously one had to buy static analysis from one vendor, and then dynamic analysis from another vendor, and whatnot, and source code composition analysis from another vendor, and then kind of integrate them all together. And that in itself could cost easily hundreds of thousands of dollars. For big software development shops, maybe not a big deal, but if you're a smaller or medium-sized player, well, what do you do? Well, this slide shows an example of some results from Deepfactor, where it's just continuously running in test and stage, and it tells you, hey, look, there's sensitive information, potentially a password that was found in an environment variable while the code was running. In addition, there's a bunch of Debian libraries that have some vulnerabilities, glibc and GCC8. You can see those vulnerabilities there. And it also does some dynamic analysis to identify that, well, there's an issue with checking cross-site request forgery tokens. So this is an example of just a new theme where there's more startups, more tools coming out that provide observability, continuous observability for CI/CD pipelines, instead of being in a typical dev, test, fix. So you can pretty much do all at the same time. So that's application security. I'll now hand it back over to Dan to chat about blockchains.
Okay, so these days, thanks, Neil. So I guess these days we have to include blockchains in any security discussions, which is great. Blockchains is an area that I really like. In fact, we do a lot of our research in blockchains now. So I can tell you personally, the reason it's exciting to me is because there are so many fascinating technical problems that are associated with blockchain, specifically kind of new applications of cryptography, new applications of decentralized and distributed systems, and even new questions in economics and game theory. So there's like enormous amount of research activity going on in the blockchain space, but it's not just a research effort. There's actually, this thing is real, right? And there's hundreds of billions of dollars now invested in various forms of blockchains, either in currencies or more sophisticated assets. I could talk forever about these blockchains. This is kind of a huge area. I think in the interest of time, I'm actually going to keep it somewhat short. So again, if this is something you'd like to learn more about, you feel free to reach out to me directly, or I teach a quarter-long course on blockchains called CS251, which anyone is welcome to register and take it. The course is available online. So what is all the excitement about? Well, most of the applications for blockchains center around in the financial space. These are financial applications. So there are cryptocurrencies like Bitcoin that I'm sure you've heard about, but there's a huge space out there of decentralized finance applications. This is what's called DeFi, that is much broader than just Bitcoin, and provides basically like a whole set of new economic tools, new financial tools that are available to anyone in the world to use, and these things simply didn't exist before. So that's kind of where most of the excitement is, and I can tell you that there's, for example, in countries that have a non-stable currency, there's a lot of interest in saving using Bitcoin, or putting one's savings into a stable currency like MakerDAO or so on. So there's quite a lot of global interest in this area. So some interesting developments that are kind of relevant to you is, well, recently large companies like Square and PayPal added direct customer support for buying cryptocurrencies. So for example, if you use the Square Cash app, you'll see that there's like a new, if you look at the bottom here, bottom right, you'll see there's a new Bitcoin tab that allows people to directly buy Bitcoin from the Square Cash app. And the same thing with PayPal. And apparently there's a lot of demand for this. So already you sort of see these cryptocurrencies going mainstream, in that the general public likes the fact that they can interact with this very sophisticated financial system. They can interact with it quite easily, and in many ways, it's a lot easier to interact with than with the traditional financial system. What's interesting is both Square and PayPal currently only support Bitcoin, which is a little bit disappointing to me, in that there are a lot of other very high value tools available in the blockchain space, like Ether for the currency for Ethereum, or as I mentioned before, DAI, the currency for MakerDAO, which is a stable currency. So there are many other tools that are available that would have been nice to see those being also available to the public through these very popular apps. So that's one development that's happened. The other thing, so obviously the other question is, if you're not in a financial space, should you care about these cryptocurrencies? And the answer is, I would like to say, is yes. And one of the big things that we're going to be seeing is a huge interest from central banks in deploying digital currencies. Yeah, so in one way or another, these are going to be related to blockchains and cryptocurrencies. And so already there's Bank of International Settlements has been putting out reports, very good reports, about the interest of central banks in digital currencies. And in particular, there's something like 40 central banks who are playing with digital currencies in one way or another. Of course, as you know, the one that's most advanced right now is the Bank of China, People's Bank of China, which already has a project in place, and actually people are already starting to use it. It's quite interesting. So the digital yuan, it's not what we would call a traditional cryptocurrencies in the traditional sense, in that it doesn't satisfy the properties of a digital currency, or of a cryptocurrency, I should say. But it is definitely a digitization of the local currency, and we're very likely to see these things happening in other parts of the world. So whether you're in a finance space, or whether you're just doing e-commerce, or any sort of application that touches money, you should be aware of the fact that digitization of the currency is taking place, and our financial rails are going to be probably changing dramatically in the coming years. Like I said, I can talk about this forever, but I think in the interest of time, maybe I'll leave it here. If you want to learn more, please check out our blockchain class. It's called CS251. All the materials are available online, and you're also very welcome to take the course when it's offered. So Neil, back to you.
Great, thank you, Dan. Okay, so I'm going to chat about the last category that we had on deck, network and infrastructure security. Of all the categories that we've talked about, this is probably the most traditional category. Probably goes back 40 years or 30, 40 years or so. And so things like firewalls, both stateless and stateful firewalls, fit into this category. Every I'd say 7 or 8 years, there's a new next gen set of firewalls that come out. The initial set of firewalls were stateless, where it didn't, where it would only looked at one packet at a time, and then there were stateful firewalls which looked at streams of packets to decide whether or not they should, say, be allowed into the network. But the network and infrastructure security area has gotten much more sophisticated over time, and it's also grown. There's been many, many subcategories. So, for instance, even just this year, Gartner said that the category of, say, network traffic analysis tools had become more sophisticated, and all these traffic analysis tools had not only been doing analysis, but have started detecting attacks and responding to them. And so they created the new category called network detection and response. And it deals with a whole bunch of threats, not just, do you let packets in or do you not let packets in? But these tools these days will in fact look for malware. They'll look for communication with malicious URLs. So they'll look deeply into packets and deeply into payloads. There's a whole bunch of other areas in this category. So things like network access control. Do I even allow a device, an endpoint device, to communicate on this network? How do I deal with distributed denial of service attacks? That also typically falls within this category. Intrusion detection and prevention, going back to tools like Boneh that came out of the research community decades ago now, are part of this network and infrastructure category. So let me chat a little bit about what's new. Given that there have been a lot of ransomware attacks, especially ransomware attacks that have been affecting strings of hospitals, I mean, the last thing that we need in the midst of a pandemic. One of the advantages of using network-based tools to do malware detection as opposed to endpoint-based tools is that if you can prevent malware from even getting to an endpoint and running on an endpoint, then the malware, first of all, doesn't have the ability to try to disable the agent on the endpoint. And number two, the malware doesn't have the ability to try to affect the detection capability. These detections are happening, using more and more artificial intelligence, whether it's machine learning, whether it's deep learning. Deep learning is significantly changing the detection rates of these tools. Most malware detection tools would traditionally use signatures, sequences of bytes in the malware binaries and known malware binaries to try to identify them. Attackers, of course, basically what they'll do before they release any new piece of malware is they'll run it through all the existing malware scanners until they come up with a variant that isn't detected by anybody, and then they'll release those. And so it's really important to leverage artificial intelligence, deep learning, machine learning, to be able to identify samples of malware that have just never been seen before. So using such approaches, you can achieve detection rates of 99% and above on unknown malware samples, while organizations like avtest.org have always looked at detection rates in terms of known malware samples. It's the detection rate for unknown malware samples that's arguably just as or more important. And so by leveraging these kinds of tools, you can bring the mean time to detect new such samples to milliseconds instead of hours, days, or months. And there's a number of companies in this space: Blue Hexagon, Cisco Stealth, ExtraHop. They're now employing these kinds of tools. Blue Hexagon has, for instance, been doing a great job, and there's some new information report that'll be coming up around that. But basically, a lot of the vendors in this space are bringing more network-based detections and using increased levels of sophistications to detect things even before they hit endpoints. And so that's what's been new in the network and infrastructure security area. One of the things that I wanted to mention as we kind of tie up is that there's a lot of cybersecurity companies out there, but we need to continue to innovate in this space. And the outcomes for cybersecurity companies are generally, much better than in other verticals. In fact, the most likely outcome, based on a study of over 3,900 funded cybersecurity companies from data from PitchBook, is that over 50% of them get acquired. So out of 3,900 companies funded over the past 15 years, over 2,000 of them have been acquired. There's relatively few that have gone out of business, only 5% or less. And there's still a bunch that are privately held. Some of these will get acquired. Some of these will go out of business. Some of them may just continue on. But this is a space that is ripe for innovation, ripe for starting new companies. If you're interested in starting a new company in this space, please feel free to reach out to me. I'd love to learn more. To just kind of summarize it, while the space is crowded and fragmented, there's always new attacks being developed. As a result, there's always new defenses that we have to develop. We have to continue raising the bar against attackers. And I noticed that there was one question that came into the Q&A around, okay, given the first slide that we showed with all these different categories, how do you stitch together a comprehensive information security program? Well, I think the wrong answer is to try to just choose one tool in each of these categories and deploy them and hope you'll be secure. Rather, I think in order to truly achieve security, you've got to look at your organization. What is your attack surface? What are the threats that your organization faces? And who knows, you might need 3 defenses from, say, one particular category because that's where the threats are in your space, and you may not need defenses in other categories. So to achieve security, it's not just as simple as choosing one defense in each category. Rather, there's a much more mindful and thoughtful approach that can be used to achieve security. But with that, we hope that for those of you that haven't been in the cybersecurity field, you'll consider coming into the field. For those of you that are in the field, I hope you've learned at least one new thing that you haven't known before. And it's an exciting space. So with that, we'll take questions.
So with that, let's go ahead and jump into Q&A. I saw that we've lined up a few of the questions, so I think it might be best to just jump into those. So Dan, what do you think about the slow migration to E2E encryption? Why is it so slow? Is it just hard, or is it not being prioritized?
Oh yeah, that's a great question. So right, so you're asking, I guess the question is about end-to-end encryption and why is it not here yet? And the answer actually is that we're getting there, right? So end-to-end encryption is not available for email. Email is kind of an old protocol. It's very difficult to make changes to because there are so many clients out there. So with email, in fact, end-to-end encryption is a bit more problematic. But if you look at all of our chat systems now, like Signal and Facebook Messenger and iMessage and all that, those are basically many of those are end-to-end encrypted. So actually, we're starting to get there. So yeah, I'd say that saying that we're not using end-to-end encryption is kind of not quite true anymore. It's true that for email, it's not happening, but then email hopefully is not going to be the prevalent mode of communication in the future. It's a good question.
Great. Neil, did you want to add anything to that?
No. I think Dan covered that quite well.
Great. So we also got some questions around cloud security, specifically around key rotation. And a lot of people were excited about that idea. So is this something for cloud-native architectures and organizations, is this an option? Is it possible to utilize updatable encryption in all cloud architecture, or are there limitations to it?
Yeah, that's again a really good question. I'm glad you guys picked up on that. So first of all, yeah, it's a different way of doing encryption. So definitely a really kind of exciting development. Let's see. So not all data can be encrypted in the cloud, right? If the cloud needs to operate on the data, if you need to do all sorts of processing of the data in the cloud, it's actually a little bit difficult to store the data encrypted. But if you're mostly using the cloud just for data retrieval and data storage, there it makes sense to actually keep the data in the cloud encrypted. And once you do have the data in the cloud encrypted, you can use these updatable encryption mechanisms to do key rotation. So what the research community has done, including kind of our work, is define ways to do updatable encryption that are relatively efficient and practical. I think the next step that will happen is either a standardization body like NIST or others will get involved in standardizing these modes of encryption, or a company like Amazon or maybe Google Cloud will go ahead and just implement one of these schemes and make them available to you. So I would not suggest that you kind of jump ahead and implement updatable encryption yourself. Implementing cryptography, as you probably know, is pretty tricky, and it's good to either follow standards or let sort of large crypto groups that have a lot of experience with implementations do it. But it's something that you can ask for, right? So what I wanted you to be aware of is that it can be done now quite practically, actually. And so it's up to you now to basically ask that, request that from your cloud provider. And if enough customers request it, of course, it'll go ahead and make that available. So yeah, basically, what I wanted to make sure is that it seems like the naive solutions don't work. And as a result, people just throw their hands up and do nothing. And it's kind of important to understand that with a bit more sophisticated cryptography, these things can actually be done. So yeah, it's a great question. I'm really glad you asked. So thank you.
Perfect, thanks. Neil, I think the next one is for you, or actually, both of you. We've seen recently just an increasing number of zero-day attacks, malware that we don't know about until suddenly you find out it's in your software. So what do you see the solution to these kinds of zero-day or attacks that are, even if they're not zero-day, are being revealed by ethical hackers before there's a solution implemented?
Sure, I'd be happy to take that. So, malware detection was traditionally dependent upon signatures, where someone, when a new piece of malware was found, they would extract a sequence of bytes, and they would look for that sequence of bytes in new unknown samples. And that approach has proved to be fragile over time and doesn't have good detection rates. So with all the new quote-unquote zero-day vulnerabilities and quote-unquote zero-day malware, to abuse the term zero-day a little bit, the idea is, how do you catch all the malware that that's never been seen or observed before by anyone? And I think that the answer there lies in artificial intelligence, techniques like both machine learning, supervised learning, as well as anomaly detection and whatnot, unsupervised learning. What they're able to do in at least the supervised cases, they look at hundreds of thousands of past samples, and they look at tens of thousands of quote unquote features in any piece of known malware. And basically, because there's such a large diversity of things that the algorithm is now looking for, rather than just a sequence of bytes, you have the capability and the possibility, by leveraging artificial intelligence, to detect a whole bunch of previously unknown malware. Even when there's a first observation of a completely new piece of malware, you can now detect it if you're using appropriate artificial intelligence and deep learning techniques. So I did sacrifice a little bit of technical accuracy in that explanation, but hopefully the answer is clear. You need to be relying on artificial intelligence much more heavily as part of your detection capability to detect new unknown malware variants.
I think we could probably do a whole other webinar just on the uses of machine learning and AI in security. I think maybe that's something that would be relevant to this audience. One thing that I wanted to add to what Neil said is that there's a large field of machine learning now called adversarial machine learning. which is kind of at the intersection of computer security and machine learning. And what it shows is that actually machine learning algorithms can be defeated quite easily in an adversarial environment. Yeah, so if you train a machine learning model to classify something, to learn some class, it's actually quite easy to design adversarial examples that would cause the machine learning algorithm, the machine learning model, to misclassify. So I think it actually would be interesting for us to do a webinar on machine learning and security, but I think that one has to be a little bit careful in that these machine learning algorithms don't do very well in adversarial environments. Yeah, and we have many examples of that now. So yeah, just wanted to add that to keep that in mind.
Yeah, thanks, Dan. If I could just add to that a little bit more as well. Basically, I think that AI raises the bar against the malware authors. But as Dan said, the second that they start using adversarial AI techniques, they're then able to evade even AI-based detection. So it is important that for any, say, company that attempts to use machine learning in malware detection to assume that the environment is going to be adversarial, and you take appropriate steps in instrumenting the algorithms appropriately, so that you don't assume all the user input is good. But I think that leveraging AI and techniques to defeat adversarial attacks against the AI, is indeed the right direction in raising the bar against the attackers.
Perfect. Well, that's actually probably a perfect ending point, because we don't have time to get to all the questions, and I want to be respectful of everybody's time. But I think given the questions that we're asking, we're already thinking about what the next webinar should be. And so I want to thank Dan Boneh and Neil Daswani again for joining us today and giving this excellent webinar on the cybersecurity market. So with that, I want to thank everyone again, and thank you, Neil and Dan. It's been a pleasure.
Yeah, thank you all. This was fun.
Thank you, Dan. Thank you, Pax.